Hi everyone, welcome to the Grammarly Meetup. My name is Vladimir Metnyu. I'm the guy who hacked Grammarly browser extension several times and decided to join the company as a product security engineer to make Grammarly safer. I will be moderating today's meetup. I hope it will be fun. Today we will have Tom Hudson, also known as Tom Nom Nom from Detectify, who will share some insights on how Detectify discovers vulnerabilities. But before we start, let me tell you a bit about a few organizational moments and today's schedule. First of all, guest safety is Grammarly's highest priority. That's why we decided to switch all our events into the online format. That's why I'm sitting alone in the empty Grammarly office. After the talk, we will have a Q&A session where you can ask Tom any questions related to the meetup topic. To ask a question, type it in the Zoom chat and I will read it out loud during the Q&A session. After the Q&A session, we will have an online networking session. So you'll have a chance to chat with Tom and Grammarly team. By the way, my team, application security team, currently runs a promotion hackathon, and we pay huge bounties for bugs in Grammarly's implementation of single sign-on feature. If you're expert in single sign-on or SAML, please give it a try. So, okay, I guess let's now get to the main part of our meetup. Probably most of you have heard about our today's speaker. Funny fact, if you search Google for Tom Nom Nom, you will likely find a 4 hours long video where Tom answers different questions related to bug bounties, offensive security, hacking, different topics. But finally, we got a chance to see Tom's talk on a defensive security topic and about such a cool security product like Detectify. So let's welcome Tom.
Hello, thank you for having me. I'm Tom. Hello, also known as Tom Nom Nom. I'm the security research tech lead at Detectify. Started back in January 2020. I've not always been in security, so I spent quite a lot of my career as a software engineer writing PHP and or JavaScript, but also some Go a bit later in life, write a bunch of open source tools and that sort of thing. And I like questions, so be thinking of questions, and then when we rattled through slides, you can ask whatever you like, even if it's not especially relevant, I guess, and I will do my best to answer. So don't be shy. So I'm going to talk to you about how we at Detectify detect vulnerabilities effectively. So the first thing I want to talk about really is what we call modules. So quite a lot of people have asked how we deal with our word lists. And we don't actually really have what you would call word lists in the traditional sense. So for me personally, sort of when I've been doing bug bounty or anything like that, or maybe doing a penetration test or something like that, word lists everywhere, coming out of my ears, in fact, just text files filled with lots and lots of words. And we don't really have those so much because it turns out that they are really, really useful for a human, but quite difficult to make sense of the results when you are a computer. So every vulnerability that we know about gets made into a module. We build these in-house, although the exploit might come from a crowdsourced researcher, which we'll talk about in a sec, or it might come from us directly as well. So we have in-house security researchers too, some very, very bright people, much smarter than me, coming up with new techniques and ideas and building them into our scanners. So a module really is a mixture of some payloads, or at least one, which could be as simple as just a file name to request, or it might be a particular path with a set of parameters or something like that. Some fingerprints for detection, so to look at the response and see whether we've actually found a vulnerability or not. And then also a great deal of metadata about that vulnerability too, such as a CVE number if it's got one, CVSS scores, references to documentation or blog posts or more information about the issue and how it can be remediated. That's sort of given to our customers. So every word that would have been on a word list is actually has all of this other information associated with it. So I mentioned crowdsource. We have a community of, I think, approaching 300 now, I think. Don't quote me on that. Researchers from all over the world who are professionally software engineers who are into security, but also professional penetration testers, full-time bug bounty hunters, and other interested parties who from time to time will happen across vulnerabilities in software that is widely used. When they do so, they can submit a proof of concept to us. We will build their proof of concept into one of our scanning engines as a module, and then we use them to scan our customers' websites. The modules get run, and then depending on the number of hits they get, the crowdsourced researchers or the hackers, or whatever you want to call them, get rewarded based on the number of hits. So it's kind of similar to bug bounty in a lot of ways, but a little bit different. You just have one sort of upfront piece of work rather than a continuing amount of work and continually looking at lots and lots of different sites. So one of the things that we really try heavily to focus on is to reduce our rate of false positives, because, you know, as I'm sure many of you are aware, if you deal with many security scanners, there'll be a lot of false positives. So, for example, if you go and run WP scan, for example, against some a particular WordPress instance, it will happily tell you that there's CVEs against all of the different WordPress plugins that you've got installed, for example. But what it doesn't tell you is whether they're actually exploitable vulnerabilities or not. And we only really want to report issues if they're actually exploitable. We don't want people to drown in noise, because if we do that too much, then people will start to ignore the results. So we need a proof of concept from our researchers. Version fingerprinting isn't really enough for us, which means we end up with a lower number of higher quality modules. At least that's the plan. So we also have a set of criteria for our modules. You know, we don't want to launch denial of service attacks against our customers, and for fairly obvious reasons. We also don't want to delete or damage their data, cause any kind of integrity problems. So attacks that require many, many requests, for example, are rarely accepted from our crowdsourced researchers. And we have to be careful things about creating data as well, which might be benign in other situations, but, you know, our scans run regularly on a schedule. So if we were registering a new user account, for example, we're going to do that every single time that module is run, which can start to interfere with systems a bit much. So we try to avoid anything that's like that. I've just seen a question in the chat that says, does the reward depend on the CVSS of a hit? Effectively, yes. So it's impact-based. We categorize things as informative, low, medium, high, and critical, but they are based off the CVSS pretty much. And also the reward for a crowdsourced researcher will depend on the specific software that it's in as well. So certain pieces of software we know a lot of our customers run, and so we increase the rewards for those pieces of software to create an incentive. So we actually have a couple of different products in which these modules can run. And one of them is asset monitoring. So the idea with asset monitoring is you tell us about one of your top level domains, and we go off and find lots of subdomains and all that sort of thing, and we monitor them. So the modules that we build for our asset monitoring product need to be quite small and lightweight. We can build these ones the fastest, and they run against the largest number of targets as well. So for our crowdsourced researchers, they are especially attractive, I suppose. And really, these modules should result in a single HTTP request. Or if it's multiple HTTP requests, then they have nothing to do with each other. They're unrelated. It might be multiple attempts with a few different variations on a payload. We also need to be able to unambiguously identify that the exploit has worked based on the response. So for example, a particular piece of text appears in the response, for example. So non-blind vulnerabilities like non-blind remote code execution, server-side request forgery, SQL injection, those kinds of things. Real common vulnerabilities like reflected cross-site scripting. And a real common one for us is information disclosure as well. So an exposed Git repository, for example, would be a really good example of that. That's something that's quite easy to detect from a single HTTP request and response. We also have our deep scan product, which is a little bit more sophisticated. So it does a lot more in terms of crawling and finding its way around a web application, and also takes more of a fuzzing sort of approach. So it might see a parameter, for example, and replace it with particular payloads to see what happens in response. So these modules take a little bit longer to build and they run against fewer targets, but it does give us a great deal more power. So if we want to do something more complex, like make multiple requests and compare them, or we want to check for out-of-band interactions. So for example, a blind server-side request forgery. We have a special service to help us with that. And just generally, when we need information from one request in order to make another. So a pretty common example of that might be, we need to make one request to find out what the values of certain parameters might be in a second request. So all of those go into our deep scan product. So when we're assessing a submission from a crowdsourced researcher, one of the first things we've got to answer is, is this a duplicate? If we already have a module for this, we don't really want to be spending time building another module, and we certainly don't want to be rewarding two people for the same thing whenever it comes up. And this can actually be quite tricky, trickier than you might think. And the reason for that is oftentimes vulnerabilities can be effectively systemic in an application. So it might be that a particular piece of software, I'm not going to name any, might be vulnerable to, let's say, cross-site scripting in just about every parameter that it has. And we might get a submission from a crowdsourced researcher identifying one particular path and one particular parameter that's vulnerable because they don't know about the others, and we build a module for it. And then we could receive a second submission from another researcher with a different path and a different parameter. Also, perhaps not realizing that there is some other more systemic issue. So there's a root cause somewhere deep in the application rather than a problem with that specific parameter. So it can be tricky. We also need to decide, is this vulnerability relevant? So like a vulnerability in Notepad is kind of cool and pretty unusual. I think Tavis Ormandy found something in Notepad a little while ago. Very cool, highly cool, but our customers, generally speaking at least, are not running web-facing instances of Notepad. So not especially useful to us. We need to figure out how likely it is a module will get hits. We'll talk a bit about that shortly. And just generally, is this software actually running anywhere? Crowdsourced researchers occasionally find issues in incredibly niche pieces of software, which again is cool, and we love to hear about it, but we can't necessarily make modules out of them. We also need to think about whether we can automate it. So we've already talked about trying not to launch denial of service attacks on our customers, for example. So, we need to figure out, is this going to be destructive if we automate it? Is it going to cause data integrity problems? We need to figure out, does this require user interaction? So a pretty common thing with some cross-site scripting vulnerabilities, for example, is that you have to click a button, or maybe it's a click tracking thing, and you have to drag something over a window, and those can be really tricky to automate as well, especially in our asset monitoring product where we're looking at a single request and a response without any kind of browser in there. Also, does it require authentication? So we have the facilities to authenticate against an application within the scanner, But if this is, for example, a random WordPress installation, for example, that we've found through crawling, we're not going to have authentication details for that installation. So we have to weigh up how likely it is we'll think we'll have an authenticated session for a module to be able to run. We have to look at how predictable the response is, how prone it's going to be to false positive, and also just how impactful is it on average. So we talked about using CVSS scores and that sort of thing already. So a couple of questions in the chat that I'll address as we're going through. So the first one is, do you use any CVE in the scanner? What are the main differences between Detectify, Akinetics, and other WAP scanners? So we do check for some CVEs, quite a lot of CVEs, as it happens. I think, although I am not intimately familiar with those other scanners, one thing I can say is that we will always try to exploit something rather than just detecting if we think that the version installed is vulnerable. And if we don't have a successful exploitation, then we don't report it. I have used other security scanners in the past where the results look impressive at first because it's identified a vulnerable version of Apache. There's some CVE attached to that particular version. But when you go and read the details on it, it turns out that the CVE affects installations with a particular module enabled in a particular configuration. And is not exploitable in the vast majority of circumstances. So that's one of the differences for us. The next question we have in here is, how does Detectify perform API scanning? The honest answer is, at the moment, relatively simplistically, it's something that we are working to improve and doing a great deal of research into at the moment. It is a difficult problem, but our deep scan product can do a certain amount of things already. So really, when you think about it, an API for the most part is just a website but for computers as opposed to a website for humans. There are some inputs in the request, some processing happens, and there are some outputs. And the only real difference is whether that output is human readable or whether it's machine readable. So a lot of the techniques that we use are applicable also. Next question we have is, does Detectify work with SPA apps, single page applications? Again, something that we're working on improving. We've made some improvements recently to that. So we have recently added support for DOM-based vulnerabilities, which I'll talk about in a few slides' time, which is highly relevant to that. Lots of questions. That's fine. So next question, in what language do security researchers submit exploits? Usually in English. I know that might sound silly. I know you mean what programming language. The real answer is it varies from a purely textual description of the vulnerability and the requests that you need to send to an exploit written in Python or Ruby or a Bash script or something like that. We're quite flexible with it. We don't expect fully automated working tools or anything like that. We just need enough that we can recreate the vulnerability and we can figure out how to automate it ourselves. Last question here for now. Does Detectify have internal statistics of detected vulnerabilities? What security vulnerability is the most popular according to our internal statistics? Do you mind sharing these statistics with external researchers? So we definitely do keep statistics. I can't tell you what's the most popular off the top of my head, I'm afraid. It's been a little while since I've looked at them. If I had to guess, it would probably be information disclosure type issues where some file has been exposed that should not have been. And part of the reason for that is just it's incredibly easy to do. It's incredibly easy to check for, and there's lots of checks for those kinds of vulnerabilities as a result. As for whether we'd mind sharing that with external researchers, I'm not sure, I'm afraid. I don't think it's my decision to make, but I will try and find out. Okay, Cool. So validating a vulnerability, this is something that we do manually. We have a few goals in mind we've already touched on. We need to decide if it's worth building a module. We need to verify the exploit works, no harm is done, and also oftentimes try to escalate the issue as well. So for figuring out if it's worth it, we're looking at the impact of the issue, which, as we said, is CVSS based for the most part. I think occasionally there's a little bit of subjectivity in CVSS scores, especially whether around sort of the high and low terminology. We also look at the number of installations as well. So if we see that there are only 10 installations worldwide using many different publicly available tools, so like Census, Shodan, Zumai, but also like GitHub and Google and that sort of thing. We do quite a lot of searching. We're unlikely to build a module for those unless it is especially easy or especially critical, or if we happen to know that one of our customers definitely has that piece of software. That's another thing we look at. We have internal metrics for fingerprints of how many customers are running which pieces of software. We make those, a version of those available to our crowdsource researchers also, so that they can see which pieces of software they might want to target if they're looking to go out and do some proactive security research rather than just submitting things that they happen to find out about in, say, a bug bounty program, for example. We also need to look at, does it work, this exploit? Does it work well, especially? So we use occasionally researcher-provided instances. So if a security research, crowdsource researcher has a copy of this software up and running somewhere accessible that we can use, then that's the easiest path to success often. We also use local instances using things like Docker containers. We have recently started leveraging Amazon AWS Marketplace as well, where there are a lot of pre-configured pieces of software where with a few clicks you can have them up and running on an EC2 instance, which is incredibly useful. But we always set up these local pieces of software wherever possible. We don't try to make the modules blind, so to speak. We also leverage the fact that we have these instances up and running to check for the stability and integrity issues resulting from an exploit, and test the reliability of the detection as well. And this has really saved us on a few occasions. So a short while ago, for example, I was partway through working on a module and testing it against a local instance. And this was a local file inclusion vulnerability. And very strangely, it turned out that the file, after being read, was deleted, which was quite unusual, but also, is the kind of thing that we really wouldn't have wanted to go on and run across all of our customers, and only found out later that it was doing it. So very, very important step. We also then try to kind of escalate and refine the proof of concept from the researcher. So occasionally vulnerabilities are actually more severe than a security researcher realizes. So as an example, we've had open redirect vulnerabilities submitted that turned out were actually susceptible to cross-site scripting with a bit more effort. Or we've seen server-side request forgery issues, which actually in particular circumstances made the system vulnerable to remote code execution instead. So if something can be more impactful, we want, firstly, our customers to know about that, but also we want our crowdsourced researchers to be fairly rewarded for that too. So we will try our best to make things more impactful where possible. Also, some of the payloads are often very complex that we get given. They might even be blocked by web application firewalls or make detection difficult in other ways. So we try to simplify and improve the payloads where possible, and also create variations of them to do things like try and get around particular WAFs, for example. We often have unfiltered access to customers' sites by having exceptions in their application firewalls and so on, but it's not always the case. So we do need to still be mindful of it. But like I say, we try and simplify the payloads as much as we can, and also try to make them so that the response is as unambiguous as possible when the vulnerability actually exists. Another question before we move on to the next slide. How many security checks, types or categories of checks does Detectify have in total? Ooh, that's a very good question. I am not 100% sure. It is somewhere in the region of 5,000 or so, although it's a little bit hard to count because of how a lot of the fuzzing types of tests work, in that they can find more than one kind of issue, if that makes sense. Lots, I think, is probably the shortest way to say that. So, and then the last thing for writing modules really is detection. You know, we have these blind and non-blind types of issues. So for if you're unfamiliar with those terms, what they really mean is a blind issue is where the exploit has worked, but there is nothing about the response to that HTTP request that triggered it that can tell you that it worked. So a classic example might be, for example, a blind remote code execution. I send some arbitrary code to a system and it is executed, but I don't get to see the response. And for a non-blind is just the opposite, almost the standard version of that, where the response does change and we can ascertain whether an exploit worked or not from it. So for non-blind issues, we tend to use text matching, regular expressions for the most part. And, you know, we have to be careful to avoid false positives, especially where, for example, it's common for text to be in the URL to be reflected in the page. It might be that the text we're looking for is also included in that file name. So that's a common source of false positive for these kinds of scanners. And just generally, we need to make sure it's not likely that that text is going to appear randomly in a page. And it's something that's happened to me several times when doing my own security assessments and that sort of thing. Is I've searched for a piece of sort of source code related text and I found it and been very excited until it turned out I was looking at a web forum where they were talking about programming. And I hadn't found a serious error. It was actually just someone asking about an error on a different system and they pasted the error message in. So those kinds of things can trip you up. Out-of-band interactions, though, can be detected using a special service. So if you're familiar with Burp Suite's collaborator tool, this is quite similar. So we have a internet-facing service which is waiting to receive connections. And we can obtain a single-use token from this service internally, and then we would use it in our exploit. So in the case of a remote code execution vulnerability, for example, we might try to execute the curl utility using a URL for our special service with this single-use token in it. And if that service receives an interaction using that token, it can correlate the two, and we know that the exploit worked. But that can work for a variety of different situations with server-side request forgery and anything that can do DNS lookups and that sort of thing. So we can do DNS-based interactions also. But to decrease false positives in general, we'll often check multiple things. So like, is the content type what we expect, for example? So I might be checking for an exposed Git repository, for example. So the path that we would be checking would be /.git/ config, for example, looking for the config file. And if a website, for whatever reason, used that as a search term instead, and it was a website about programming, it might show up information about a Git config file. You never know. It's entirely possible. So some of our text might match. If we check the content type and see that it's a text HTML, and that's done not just by looking at the header, but there's also some sniffing and type checking going on there. It's a little bit more fuzzy. We would know that we can rule that out. And also, is the response code what we expect? Is it an HTTP? Is it 404 not found? And if so, that probably means we didn't find the file we were looking for, even if the text did match. So a question before we move on. Do you have any plans to integrate Detectify as a plugin or in any other way with Burp Suite? We do not. Technically, Burp Suite Enterprise is effectively a competing product. I think it is fairly unlikely to happen because our product is targeted at people testing their own things, and most people using Burp Suite are testing other people's things. So to add a site to Detectify, you would need to verify ownership of the domain and all that sort of thing. So I think the use cases for that would be quite limited. Okay. So something I made reference to earlier on is DOM-based issues, and this is something that we've been working on improving recently. So modern web applications have many issues that are client-side rather than server-side, and they can be quite difficult to detect, but incredibly difficult to detect without producing false positives as well. So all of the stuff that we've been talking about so far is about firing off an HTTP request and analyzing the response. And if the vulnerability is in some JavaScript, technically speaking, we could do some analysis on that JavaScript and attempt to figure out whether a vulnerability exists. And I don't know how many of you have attempted to do static analysis on JavaScript, but it turns out to be very, very difficult. Especially in a complex web application where there's lots of different pieces of JavaScript interacting, it can be difficult to work out if a piece of JavaScript will even execute, let alone if it is vulnerable to something. So one thing that we started doing is we run actual client-side exploits in a headless browser as part of our scans that detect that they're definitely executed. That's something that I've worked on, and it seems to work quite well, which I'm very pleased about. So we run actual exploits and we hook into certain aspects of the browser to detect that our code has definitely run. So in theory, we should have 0 false positive rate when we detect these DOM-based issues, which is good. So sometimes the submissions that we get from crowdsourced researchers are 0 days. If you're not familiar with the term, it's a bug that is not known, a vulnerability, should I say, that's not known about yet. It's not patched. It is day 0. We have just found out about it, and no one's been able to deal with it yet. And we have to deal with these submissions slightly differently. So when a crowdsourced researcher submits a module, they have an option to mark the submission as being a 0 day. After we've verified the submission is valid, one of the things we do is we contact the vendor. We encourage the security researcher to do this also. We don't especially want to be in the business of helping people with disclosure of issues and that sort of thing, but we do need to make sure the vendor is definitely aware. And we actually have had really good experience with the vast majority of people that we've contacted, I would like to say. We give them 45 days notice for the module being released, because if we release the module before that, we're effectively, and detect it on a customer, we're effectively making that information public. There's nothing stopping that customer from going and saying, we've had this issue detected and we've done some Googling and no one knows anything about it. I think that would be bad. But if the vendor discloses the issue before that, then we'll release the module early. So as soon as possible, effectively. So, because we have lots and lots of customers, we also end up working at quite a large scale, and definitely a very different scale to an individual pen tester or bug bounty hunter or something like that, or even a small team of penetration testers. So when scanning on a single target, for example, you might spend an hour, 2 hours, an entire day perhaps, brute forcing a single parameter that you have identified as being particularly important. And we can't do that because I don't think there's enough compute available in AWS to do that for every single URL, for every single parameter that we come across, and so on. So we have to be, amongst other things, more selective when we're scanning these large attack surfaces across lots of different targets. So we use fingerprinting quite extensively. So we, for example, have a bunch of different ways to detect that you're running WordPress. WordPress always seems to be the example software that gets used. And if we haven't detected a WordPress install, we're not going to send many thousands of different WordPress specific payloads. We're not going to run those modules at all and reduce the amount of time that we have to send. Similarly, for identifying technology stack, if we've seen that you are running PHP on Apache, we're not going to be sending .NET specific payloads, and so on and so forth. So that's one of the main mitigations that we have against that. And also, as we mentioned, if we have a submission from a crowdsourced researcher that requires brute forcing or something like that, we have to turn those down unless there's some very, very clever trick to get around those restrictions. We have a few more questions to go through. Do you have any plans to provide simple plans with recurring monitoring and exploiting for bug hunters? That's not something that we have planned. I'd say our target audience is companies themselves primarily, and it's not something that I would have control over from my position. It would be someone in product you'd have to talk to about that, I'm afraid. Next question is, do you have any plans to provide, oh, that's the same question again. Sorry, just came up twice. How many zero-day submissions has Detectify received to date? Oh my goodness. I don't know about to date. I can tell you there's been more than 50 in the last 2 months, which is not completely representative of all time because a number of submissions is growing, and things are quite peaky. They change over time, but we've received quite a large number recently, for sure. Cool. So kind of the last sort of thing I want to talk about really is the future of web application scanning. And I don't have a great deal of insight here, or at least not a great deal more than anyone else does. But I still find it interesting to see what the trends in web applications are. So web applications are becoming incredibly complex. I've worked on a few myself, which would give operating systems and web browsers and things that are run for their money in terms of complexity. But more and more logic is also being done in the browser, so in single page applications. I think we're going to be needing to make increasing use of automation using headless browsers because that static analysis of JavaScript is so hard, it's such a difficult thing to do. And increasingly, effectively every request we send to a server results in the same thing, which is some HTML on a giant JavaScript file. And it's almost impossible to make any sense of that without using a browser engine and JavaScript engine itself. There are a lot of challenges with that as well, just because so much tooling is not expecting to be in that kind of environment. And also, modern web applications are often composed of many, many services. This isn't necessarily a new thing, but I think it's becoming increasingly common. So what we would call the middleware attack surface is getting much larger as a result. So That's kind of the glue layer between all of the individual services. Things like load balancers, for example, often have a remarkable amount of business logic in them. And they also tend not to have access to things like access control databases and things like that. The code tends to be a bit more simplistic, often written by a different team even. So there are many chances for differences between what the load balancer thinks about a request and what the backend thinks about a request, or what the next API down thinks about a particular request or a particular value, especially when those individual pieces are written in different languages. For example, they can often have very different interpretations of data, and that can cause can create effectively this new attack surface that never existed before. Quick question before we move on. As an AppSec engineer, can I leverage Detectify engine for my own security issues database? That's not something that is possible, I'm afraid, if I've understood your question correctly. Sorry about that. And then lastly, I want to talk a little bit about machine learning as part of this thing of talking about the future. So big disclaimer, I am not an expert on machine learning. I know about its uses and its strengths and weaknesses to an extent. And also it's not something that we're using now, but it's something that I think is going to become increasingly relevant in the future. So, I think machine learning in the security world is still very new. It's new in a lot of industries, of course. Many of the use cases that I've seen and heard about sort of on the blue team side, people who are trying to detect people trying to attack them. So things like smarter web application firewalls that can look for patterns in requests and so on. Intrusion detection systems as well seems to be quite a large area in the machine learning side of the security world, along with anomaly detection, so looking for things in log files that should not be there, for example. And also I've seen tell of people doing memory dump analysis for local applications that are running on their machines to try and figure out whether there's any integrity issues there, which is very interesting. Slightly more relevant to our side of things, though, is sort of more the offensive side of that. And the things I'm aware of going on in the machine learning world there are things like dynamic word list expansion. So we talked about word lists a little bit earlier on, and they're an incredibly useful tool for testing the security of an application. But oftentimes they're incredibly generic. So they will have, all of the common words that might appear in source code, for example, or in URLs or in subdomains or something like that. And very often a web application will have incredibly specific terms which are not in use anywhere else. So they're not going to be in those generic word lists. And I think one of the places that machine learning can really help there is by looking at the responses from an application and figuring out which of these words would be useful to be in a custom word list or set of payloads for a particular service or even for a particular endpoint as well. It's possible as well, I think, that those lists could even be generated on the fly in response to other words that have already been checked. So if a particular word causes a particular behavior to happen, for example, it might latch onto that and generate variations of something similar. I've talked to people about how they're using machine learning to try and predict vulnerabilities based on a URL. So, one can never really understand how a neural network does what it does, but the general idea, I imagine, is along the lines of if a particular parameter starts with a slash, for example, you might have a reasonable guess that maybe it's referring to a file name or a URL or something like that. And that would influence the kinds of vulnerabilities that might occur there. Also, solving captchas, I think, is a relatively not low tech, but simple use of machine learning. I guess the irony there is that all of us filling out captchas every time we do a slightly unusual Google search have been training machines to understand the puzzles that we've been solving instead. And also generally, I think detecting interesting responses is a really big problem for where you don't have a well-defined module already. So you're doing some kind of fuzzing on a parameter like our deep scan product does. There are certain things we can know to always look for, but it can be quite tricky to automatically detect whether a response is interesting or not in comparison to others, especially because so often the responses from a web application can differ slightly, whether that's something including a different advertisement every time you load it, or maybe there's some other random data. Maybe it's just loading the latest tweets from a particular Twitter account or something, for example. The content can change quite significantly. So something that could identify truly interesting responses would be incredibly useful in this situation. So in summary then, the way we do things is we get high quality research from our community, verify and refine the techniques, and then we do our best to automate them. So that was my last slide, but there's a couple more questions come through. And we have plenty of time for questions. We've got a good 10 minutes or so, I think. So if there are more, relevant or not, feel free to stick them in the chat and I will do my best.
Tom, thank you for a great talk. Any attendees, if you have any questions to Tom, please type your questions in the chat. We still have some time. Also, Tom, thanks for answering questions during the talk. Yeah, we have some questions in the chat. Do you have any? Oh, it's my question. Do you have any security checks for window post message bugs or bugs in progressive web apps like cache bugs in app cache or service workers?
Yes, we do actually. So we have a set of effectively fuzzing checks for window.postMessage issues. So for anyone who's not familiar, when two browser windows want to communicate with each other across different domains, one of the ways they can do that is using this post-message API. So if you open a window with window.open, so like what used to be a pop-up window, but now would probably just be a new tab, or in an iframe or something like that. Even if it's on a different domain, you can send this message to it client side with this post-message API. And oftentimes the handling of that is not done so well on the receiving end and can create issues like data leakage, but more commonly cross-site scripting as well. So we do have some checks for those.
Thanks for the answer. Next question. Looks like you have lots of interesting data that could be useful for WAF. Any thoughts in this way?
Yes, I suppose we probably do. Web application firewalls are not our area of business. I suppose it's possible, although it wouldn't be my decision if a vendor wanted to work with us on that. My personal feeling on web application firewalls is that they are, again, incredibly difficult to implement. You can look at all of the different payloads that we have, and maybe you could put them in a machine learning system or something like that. And I'm not entirely convinced you would have a better web application firewall. I think you would block a lot of non-malicious traffic. So one of the examples I often give of where a WAF can break down is they will block, for example, the word alert followed by an opening bracket, because a JavaScript alert box is pretty much the de facto standard for someone wanting to demonstrate a cross-site scripting vulnerability, because it's very much in your face. But On the other hand, I found situations where alert was blocked, but eval is not, which is the way you execute arbitrary code in JavaScript. And there's a lot of obfuscation and things you can do there. So I think that's the danger there of using, for example, the payloads that we have where we want to be quite overt and identify a vulnerability definitely exists versus what you actually want to block, which is genuinely malicious traffic instead.
So does it mean that Detectify doesn't have any plans to create a separate WAF product?
Not that I'm aware of, no.
Okay. Next question: does Detectify has any tools, internal scripting for passing short-time auth tokens challenge?
Passing short-time auth tokens challenge. I'm not sure I understand the question, I'm afraid.
I guess the question is about like GBT tokens with a short lifetime, short session expiration. I'm not sure too.
Yeah. I think given that I don't especially understand, I think the answer would probably have to be no, we don't.
Maybe the question is it possible for Detectify to generate sessions dynamically? Exactly. Okay.
Say that again, sorry.
The I answered exactly, but I'm not sure what this response is about. I thought that short timeout tokens challenge, maybe that means is it possible for Detectify to generate sessions dynamically on web application?
Okay, so generally speaking, we are not authenticated to an application in the normal state. We are sometimes about JSON Web Tokens. Okay, no, we do not. So we try to make our tests as stateless as possible. So it's as though that they've only just gained a session. Like we don't reuse those tokens unless we have to for an exploit to work. The exception to that is if a customer has configured their, what we call a scan profile, so a setup for a particular domain to be authenticated. And there's a few different ways they can do that. We have a browser extension that you can use to record a login flow that we can replay. And if we become not authenticated anymore, we can replay that. Also, you can provide sort of a HTTP bearer authentication tokens directly and so on, but we don't have any tooling other than that.
Okay, thanks for the answer. Next question is again from me. Would it be hard for Detectify to collect and anonymize data sets of interesting request response for machine learning? Because you mentioned that it makes sense to take a look at interesting responses. So is it possible for Detectify to generate a data set for hackers? Maybe you have any plans to bring machine learning in offensive security?
I think it's technically possible, although anonymization is incredibly difficult in that situation because our responses will inevitably include information about who our customers are, for example, and without manually reviewing all of them and trying to redact basically everything that would reveal who the customer was or what a particular page was, for example, or where, you know, in our case, where a vulnerability was, because those interesting responses are going to be the ones where there was a vulnerability, right? So
it seems like Grammarly, yeah.
Yeah.
It seems like Grammarly can help you with anonymization.
Perhaps so. But you know,
some advanced technologies here. Yeah.
The web being the web, any sort of 5 or 6 word sequence of words is enough to find someone on Google, right? Yeah. Pretty much. So I think the anonymization there would be very difficult, especially because if you changed enough of it that it was anonymous, I think the data would be so different that the model probably wouldn't do a great job of learning. But again, I'm not a machine learning expert, so I'm happy to be schooled on that.
I'm curious whether it's possible to create like abstract representation of vulnerabilities and extract some general patterns for machine learning. But yeah, we need some experts here. I have one more question to you, Tom.
Yeah.
As you said, Detectify works at a certain scale, at a huge scale. And let's compare this to bug bounty. Many bug bounty hunters try to scale their security checks and tricks too. But of course, their scope is smaller. And the question is a bit personal, maybe. What were the key challenges for you to switch from doing bug hunting to contributing to Detectify Web Scanner, which is actually a huge platform for scaling security checks? What was the most like the key motivation for you?
Ooh, that's a really good question. I think most of my challenges personally haven't really been technical that much. I mentioned that I worked on some of the research for introducing scanning for DOM-based vulnerabilities, for example. That was quite challenging. There was a lot of problems to solve there that I wouldn't have been solving if I was doing just bug bounty. For example, I'd be probably looking for things manually. I kind of old school in that way. I quite like doing the manual stuff when I'm not on the clock, so to speak. But a little off topic perhaps, but I think the most challenging thing for me joining Detectify has been trying to be a good leader and a good manager, which, I have a team of researchers who report to me, and trying to help them become the best researchers and best engineers that they can be. I think is probably the most challenging thing for me that wouldn't crop up in sort of a, doing bug bounty with friends sort of a situation.
Do you feel like you make the web safer each day? Every day you make the web a bit safer, a bit better?
Yes, I do.
Oh, cool.
A lot of customers that we have provide services to lots of people and have very personal information for a very large number of people. And every time we find a vulnerability that could have endangered those people and it gets fixed, we've made it safer for those people.
I'm curious about internal Detectify statistics because it seems to be a very interesting data. Types of vulnerabilities, how many security checks you have, and just probably I need to say that many bug hunters use Detectify's payloads for deer busting, for fuzzing, for any other activities. Yeah, and they share these payloads in chats.
Yeah, so I'm aware that some of our payloads have been leaked, I suppose. But I think what's interesting, I think I've even been offered some at some point. I've got Detectify's payload list. We only kind of have, right? So you can sign up for Detectify and run it against a server and see what we send. But what you won't see is all of the detection part, which puts the detect in Detectify. What is it that we're looking for in the responses to be able to see if an exploit has fired properly? Also, because we do so much fingerprinting for things, if you're not running a particular piece of software, we're not going to send the payloads at all. So there'll be a lot. I'm sure those lists are probably fairly good for a lot of people, and they might have found bugs with them, but they haven't got the scanning engine that runs it. They haven't got all of the metadata about it. They haven't got the detection strings and checks we do. And like I say, anything that we didn't fingerprint them as running, they won't have any of the payloads for those either. So I think it's not something that's ever going to stop people doing things like that. I think but I don't think we're especially worried about it, but we would never encourage it.
Okay, another question. Do you like Detectify is a scaler of security checks? How do you estimate which security check do you want to add to security scanning cycle? I guess not all security scanning, not all security checks go to the final security scan for a single website, because like scanning a website infinitely, it's not a good technical solution.
Yeah.
So yeah.
So like I said, there's a lot of fingerprinting that goes on. There's a certain amount of effectively graph-like behavior where modules have dependencies and things like that as well. So if one module has fired, then others will fire in response. And also the opposite way around as well. There's things that we'll only check for if we haven't yet already detected something, if that makes sense.
We have a question to both of you. From your experience, how does bug bounty program and Detectify compete each other for the same websites?
That's a good question.
Yeah, what do you think, Tom?
It's a good question. There are always going to be things that automated scanners cannot find, and that bug bounty hunters are very good at finding. So, for example, business logic issues are a kind of a really, really good example where a bug bounty hunter can, sign up for 2 different accounts and look for IDORs between them. So, insecure direct object references. So, for example, being able to see someone else's private messages on a social media platform, for example. Automated scanners are not going to detect those things. Pretty much, I think, until we have general purpose AI, probably would be my guess. And, if we've got general purpose AI, then we've solved so many other problems that it doesn't even, we don't even need to worry about it. There are, bug bounty hunters who run their own scanners against targets. But I think it's quite rare for them to have the coverage that we have, just because we have 300 or so researchers in our crowdsource community submitting such a wide variety of things to us, from having a very wide variety of expertise. It's pretty common for us to get something that's not a 0-day necessarily, but might be a common misconfiguration from a crowdsourced researcher in a particular piece of software. So it's not something that's ever going to get patched by a vendor. It's something that customers have to fix individually. So it might be that we end up being essentially the only people with a check for that. And because we have the wisdom of crowds on our side, we end up with a really nice wide variety of checks.
Yeah, and from my opinion, we have Detectified Grammarly, and I think that definitely bug hunters and web application scanners, particularly Detectify, they complement each other, because Detectify and probably Detectify, I wouldn't mention any other web application scanners. Detectify is great because of monitoring, because of CVE monitoring. It's pretty easy to set up Detectify for authorized scans, but there are a few technical problems. For example, it's hard to set up Detectify behind VPN, behind certain applications. For example, we at Grammarly heavily use AWS ALB plus Okta plus ADP, and like we don't want to. There are certain technical decisions, and due to the decisions, we don't scan all our internal apps so far. But at the same time, yeah, we cannot give privileged access to hackers so far. But we expect that we will roll out Detectify. We will deploy Detectify security checks to all our internal web applications, and we expect that in the next year we will have a private program for our HackerOne researchers, and our researchers will have a chance to hack internal applications. And I guess we will have some statistics, and we will be able to compare the Detectify web scanner and individual researchers or bug hunters. Yeah, kind of. Also, Tom, in your opinion, what will be the future of defensive solution sets and web scanners in like 5 years or 10
5
years?
years. Ooh, this is a good question. Like we've already talked about a little bit, I think machine learning will start to play a part in it. I don't think it will be a major role by then, unless there's some quite dramatic improvements in that world in the next 5 years. I think there will be a great deal of improvements to scanning single page applications. I think, whenever anything new in the technology world comes out, security and all of the non-functional requirements, as it were, like security, scalability, performance, those things all tend to come later and sort of left to people in different parts of the industry, in different industries, to figure out. So, single page applications are very, very common now. And for the most part, I think the security industry is playing catch up. So I think things will improve there dramatically.
What do you think? Will we need to set up black box scanners like Detectify in future, or it would be sufficient to scan the application with static analysis, with some static analysis tools like LGTM or CodeQL?
I think that sort of the black box scanners from the outside looking in will still be important. And I think that because, static analysis is incredibly useful, and like those kinds of checks. It's a bit like having unit tests in a lot of ways. You can verify easily that an individual component is broken, but actually, there's a lot of attack service in what I referred to earlier as the middleware and how those things join together, and in differences between them as well. A great deal of vulnerabilities in applications are actually not in one place, but they are in the interaction between two. For example, if you have slightly different validation for your usernames between registration and login, for example, because they're handled by different microservices and the code's not quite in sync, those sorts of things you can't catch with static analysis of a single application. You have to be looking at the entire application in place.
Yeah, it's hard to implement integration tests for different languages, for different services. Thanks for answering all these questions. Thanks to our attendees. Thanks you all for joining us today.